Good morning, 8th grade. We're moving on to lesson 69, direct variations. And I'm going to kind of go along in the book today because it'd be confusing on a whiteboard. So, underneath new concepts there, it says, recall that when two variables are proportional, the value of the one variable can be found by multiplying the other by a constant factor. We call this relationship between the variables direct variation. You have the y equals k times x. Sorry, trying to figure this out here. In the equation, x and y are the variables, and k is the constant multiplier, called the constant of proportionality. The constant of proportionality might be a unit rate, a scale factor, a unit multiplier, or an unchanging number that relates the two variables. Here are some examples of direct variation. Can you find the variables and the constant of proportionality in each example? So the two variables in the total pay equals $12 times hours worked. It's the hours worked and the total pay, okay? And then $12 is the constant. So the numbers are the constants, okay? So the next one, miles traveled and hours traveled are the variables, and 60 miles per hour is the constant. This one, the perimeter and the side length are the variables, and the constant is 4. Turning the page. Okay, so characteristics of direct variation. When one variable is 0, the other is 0, the graph of the equation intersects the origin. As one variable changes, the other variable changes by a constant factor. The graph is a line. Okay, we can solve the equation y equals kx for k by dividing both sides of the equation by x. Okay, so moving on to example 1, it says, which of the following is an example of direct variation? The variables are underlined. So A, the taxi company charges $3 to start the ride plus $2 per mile. Okay? So the variables are underlined, the dollars and the mile. You make a table there, and it's dollars equals $2 per mile, okay, plus the $3 that the company charges to start the ride. Okay, so if you go 1 mile, it's going to be $5, because 2 plus 3, and then you get 5 over 1. If you go 2 miles, it's $7. Okay, so 2 times 2 is 4, plus 3 is 7. 7 over 2. If you simplify that, it's going to be 3 and 3.5. Okay, if you go 3 miles, then it's $9. 3 times 2 is 6, plus 3 is 9. 9 over 3, okay? And then 4 miles is $11. So all these, they're not really proportional, are they? Because they don't simplify to the same number, okay? So then moving on to the next one, the area of the square is the square of the length of its sides. So you have area equals side squared. The side is 1, the area is 1 over 1. 2, then you square 2, that's 4 over 2. Okay, so that's 1, that's 2. So this is becoming that it's not proportional as well, because you do 3, and then 3 squared is 9 over 3. 4 squared is 16 over 4. Okay, moving on to the last one, the perimeter. On C, the perimeter of a square is 4 times the length of its side. Okay, so the equation for that is P equals 4S, because it's 4 times its side. So if you have 1 and 4 over 1, that reduces to 4. 2, you have 8 over 2, that reduces to 4. 3 is 12 over 3, that reduces to 4. 4, 16 over 4, that reduces to 4. This one here is proportional. Of these three, the only example of direct variation is the relationship between the perimeter of the square and its side length. In every number pair, the ratio reduces to 4. The relationship is proportional. In other examples, the ratios vary. The relationships are not proportional. So if we graph those, okay, we can also identify direct variation from a graph. The three relationships from example 1 are graphed below. So in A, you start out at 3, okay? You don't start out at 0, okay? So we know, yes, it's a linear line, okay? But you don't start at 0, so that is not proportional. This one starts at 0, but it's not a linear line. It's not straight, so that is not proportional. This one, the third one, the perimeter, we start at 0, and it's a line, and each one is 4 units apart. That is rational. That's a rational, sorry. It's a rational relationship, okay? So, moving on. In a direct variation relationship, the value of one variable depends on the value of the other. One variable is independent, like the number of hours a person works, and the other is dependent, like the total pay of the person earns. In a table, the independent variable is typically placed in the first column, and the dependent variable is in the second column. On a graph, the independent variable is typically pointed on the horizontal axis and the dependent variable on the vertical axis. The constant of proportionality is the ratio of the dependent variable to the independent variable. Okay? So if you read that example, Doubleday doubled every number. Eunice said, the table shows 4 numbers. Eunice said, and Doubleday's replies. Sketch a graph of all the numbers Eunice and Doubleday could say. In the relationship of numbers, they say an example of direct variation. Write an equation for the relationship. What is the constant of proportionality? So if you look here, in the left column, you have, or in your first column, you typically have the dependent variable. Okay? In the second column, you have the independent variable. Okay? So Eunice said 2 and 4, 1 and 2, -1 and 2, -2 and 4. So they kind of they double every time, don't they? Okay? Moving on to the second part of graphing it. Okay? If we graph this, we graph those pairs that we had on the other side. And it's -1, -2, and then you have 1 and 2, and then you have 2, and it looks like 4, okay, and so forth. This graphed a linear line, correct? Okay, so relationship is an example of direct variation after you graph it. And an equation would be Doubleday equals 2 times what Eunice said. We had mentioned that before. They double, okay, each time, and each one reduces to 2. So that's a direct variation. They are rational, okay, and so forth. Okay? Example 3, I'm sorry. Jared earns $12 an hour helping a painter. Create a table that shows his pay for 1, 2, 3, and 4 hours of work. Is Jared's pay for hours worked an example of direct variation? If so, what is the constant of proportionality? Okay, so if you look here in the graph, 1 hour, $12, 2 hours, 24, 3 hours, 36, 4 hours, 48. That's a table. Okay, this is your dependent, and this is your independent. And each one reduces to $12 because they're getting $12 an hour. So this is an example of direct variation, and the constant of proportionality is 12. Okay? Okay, that concludes today's lesson. Hopefully that worked out for you. I know my phone was kind of shaky at times because I'm holding it. Your assignment is evens. And have a great day, and I'll talk to you tomorrow.